this kind of architecture, that is VLIW, that is very long instruction word. Now in this type of architecture, what happen, uh, we are making a group of instructions, we are making a group of instruction, because क्या होता था आपके सुपर स्केलर आर्किटेक्चर में हार्डवेयर कास्ट एंड द कॉम्प्लेक्सिटी ऑफ द सुपर scalar scheduler is major consideration, because there is a vertical wedge, there is a horizontal wedge. So to address this issue, VLIW processor rely on a compiler time analysis to identify and bundle together instruction that can be executed concurrently. तो यहाँ पे हम लोग क्या करने वाले, we are not following the order of the instruction. Instead of that, we are observing the code fragments. In that code fragments, those instructions are independent. Okay, we are making the bundles of that instructions. Okay, suppose there are 10 instruction in your code. Okay, and in out of these 10 instructions, suppose 3 instructions are independent to each other, so we are making a group of these 3 instruction, we are making the group, and that group is called as a word. See here, it is from name also you can get the type of architecture, very long instruction word. Long instruction means what? Number more than one instruction, we are making a group of that one, and that group it is called as a word, and then we are sending to that group to the one of the processor. So these instruction जो भी group में आपके are packed and dispatched together, and thus the name is very long instruction word. So this concept was used with some commercial success in multi-flow trace machine, that is called as a circa, and variant of this concept are employed in the Intel processor, that is IA64. Okay, so but there is again some limitations and some advantage of your VLIW architecture. If you are considering, because what happened, your superscalar architecture is executed at the runtime, where a VLIW processor is executing at the कंपाइलर टाइम. सो क्या करेगा आप लोग, जो कंपाइलर करेगा सारे जो भी पेजेस है आपके, लाइक फेज इंस्ट्रक्शन, डिकोड इंस्ट्रक्शन, all that responsibility is assigned to the compiler. So what happen, you are going to increase the overhead of your compiler. Again we are what happen, we are trying to reducing the dependency in the VLI architecture, because what happened, that is a main constraint in the superscalar, or there is a limitations of your superscalar. डिपेंडेंसी हम लोग कैसे रिड्यूस कर रहे हैं इन केस ऑफ VLIW architecture, we are making a group of those instructions which are independent to each other. Okay, then there is some limitation. What happen, we are increasing the complexity of your compiler. Then second is we cannot run the your instruction in the dynamic environment, because all instructions are be run at a compile time. So compiler however do not have a runtime information such as a cache miss. Scheduling is therefore inherently conservative, so and that is the limitations of your uh, VLIW. Then again there is a problem of superscalar architecture with the branch instruction and the predictions of the branch instruction. Same thing is happen in the VLIW. So branch and the memory prediction is more difficult part in the VLIW architecture. So VLIW performance is highly dependent on the compiler. A number of techniques such as the loop unrolling, speculative execution, branch predictions are critical in case of VLIW architecture. In case of superscalar architectures, we can have the 4 instructions at a time, whereas in VLIW architecture we can implement 4-way up to starting with the 4-way to up to 8-way, means we can consider the maximum 8 instruction into a group. Now before discussing these VLI examples, okay, one thing is that suppose you need to observe your code fragment. Okay, see where VLI architecture is also depend on the functional units. Okay, how many functional units are used by your processor? Suppose one code fragment is there where we having a load and store instruction, instruction, and we your processor using only two functional units for that one. For addition, you are having only one functional units, and for multiplication, you are having only one functional unit. So what happen if you are considering the group? Suppose this is a processor. One group is this one, another group is this one group of instruction, and another third group of instruction is there, and all these groups are independent to each other. But in a one group of instructions, you can consider one and add instruction and one multiple instruction. See here, you can consider one add instruction here, one multiple instruction here. It's okay, but within a one group, आपको जो भी ग्रुप आपने बनाया है वहाँ पे you cannot consider two add instruction or two multiple instruction at a time, because what happen, you having only one functional unit for the operation purpose. Okay, so you need to take care of this when we are using the VLIW architecture. Now consider this is the one example. Okay, now we want to perform this operation. For this operation, if you consider normally serial execution or this scalar execution, so how many instructions you need to be execute? So if you calculate this instruction, load A, आपको पहले load A करना पड़ेगा, then B, X, then load B, then Y, Z, C and Z, then you need to perform the multiple operation A, X, B, Y, C, Z, and then you have to perform the addition operation A, X, B, Y, and then A, X plus C, Z. Okay, because your result is stored in the addition result is stored in the X register. So in this way, you need to be performed. These are the different instructions. So total 11 instructions you require. But if I am considering the VLI architecture, so here I can execute two instruction. Okay, then so first t is equal to 1, then in t is equal to 2, we can make a group of these two instruction. Okay, that is load B, load Y, both are independent to each other, and multiplication A comma X. Okay, your result will be this one actually. So this A comma X, again it is a independent to this one. Okay, this group of two instruction, load B and load Y. So you can consider, and already you loaded this value A and X, so you can perform the multiple operation. At t is equal to 3, what happen, load C, load Z, at the same time you can perform the multiple operation in between B and Y, because this is a independent to this one, load C and load Z, and already the value of B and Y is loaded. At 4, you can perform the multiplication operation of C and Z, and at the same time you can perform the operation addition, one addition operation, AX plus BY, and then lastly you are performing addition operation AX comma CZ, and you are storing the result into AX. Okay, so here t is equal to 11 if you are using the scalar execution, and here if you are using the VLIW. Okay, because this is a group second group, at t is equal to 3, we are considering all independent instructions. Okay, so you require only t is equal to 5. If you are using the superscalar architecture here for this same example, you require the 6 to 7 uh, instructions. Okay, for the executions purpose, if you are considering the two-way superscalar architecture. So what happen if a scalar architecture execution 11 instruction, where superscalar 7 instruction, and if you are using the VLIW, then only 5 time is in one cycle. Okay, t is equal to 5, at 5 your all the code fragments will be means all instruction in the code fragments will be executed. So that is the advantage of your VLI architecture. Now most of the time the questions will be asked regarding the difference between the superscalar and the VLIW. So just an instruction per unit time, two instruction, 4 instruction maximum, one instruction per unit time, but work is equal to n, because we are having a one instruction, one word, but within that one word there are number of independent instructions are there, so the work is equal to n. It looks another n instruction. If it is two scalar architecture, two-way scalar superscalar architecture, it will check the new two instruction for the execution purpose, and both instructions should be independent. It looks next large instruction or group of instruction, cost expensive, obviously it is a cost cheaper. Then instruction that are issue and scheduled dynamically by the hardware, but here we are using the compiler, so we it will not run in the dynamic environment. Instruction ordering, either you can have the in order or the out of order issue in case of superscalar, but in case of VLIW we are having a out of order issue, because we are not following the sequence, we are just pick upping the from the code fragment, we are just pick upping the instructions which are independent, and we are making a group of that one, so it is using the out of order issue. So this is a basic difference between your superscalar and the VLIW architecture. Hope you are getting this point, and the difference between these two architecture. These two architecture is used for the parallel computing purpose.